Hi guys, Ms. Burns here. So we're going to take a look at section P.5, which is on factoring. And hopefully you did a little bit of this in high school, or if you took intermediate algebra, you should have done some factoring in there. I would recommend that you get out the factoring roadmap, the handout that I gave you in class, because I think that will help you sort of see what we're doing and why we're doing different things while we're doing each example. So if you look at the handout, the first thing it says to do is always look for a GCF. So remember, GCF stands for greatest common factor. So let's look at an example where we're going to use the GCF to factor. So this is example 1, part A. And we're going to factor the expression 18x cubed plus 27x squared. So what I want you to take a look at is look at the two numbers first. Your numbers are 18 and 27, and think about what is the largest factor that goes into both 18 and 27. 3 works, 3 goes into both of those. However, something bigger works, and that would be 9. So as far as the numbers go here, 9 is the largest factor that goes into both 18 and 27. So I'm going to write over here, our GCF is 9. And then for the variables, you want to look at, if they both have x's, for example, you want to look at the lowest powered term. So between x cubed and x squared, the lowest power term would be x squared. So our GCF is going to be 9x squared. So remember that the GCF, taking out factoring using a GCF, is similar to, it's the reverse of the distributive property, right? So we're taking out 9x squared, and I'm going to put that in front, and then we're going to put a parentheses. And then however many terms you start with in the original expression, that's how many terms need to end up in your parentheses. So ask yourself, what would I multiply 9x squared by so that I get 18x to the third? And so that would be 2x. And then for the other term, what would I multiply 9x squared by so that I get 27x squared? And that would just be 3. It doesn't need any other variable because it only needed x squared, and that's what we had as part of our GCF. So the only thing we can do with this is factor out the GCF. We have 9x squared times 2x plus 3, and that's going to be completely factored. Let's look at another example that factors using the GCF. So we've got 5x to the third plus 10x squared minus 25x. So this time we have 3 terms, and I want you to start with the numbers. The numbers we have are 5, 10, and 25. And think about what we can take out of all of those. Hopefully you see that it's a 5. So our GCF is going to contain a 5. And then they all contain x. The lowest powered term is x to the first power down here at the end. So our GCF is just going to be 5x. So I'm going to take the original expression. I'm going to put 5x in front of the parentheses. Now this time I started with 3 terms, so I need to have 3 terms in the parentheses. So 5x times what gives me 5x to the third, and that would just be x squared. 5x times what gives me 10x squared, and that would just be 2x. And then 5x times what gives me negative 25x, and that would just be negative 5. You can always check these, by the way, remember, by multiplying or redistributing them. You don't have to do that every time, but if you're ever not sure, you just want to make sure you got it right, try redistributing. 5x times x squared, we would have 5x to the third. 5x times 2x, we would have 10x squared. 5x times negative 5, we would have negative 25x. And notice that's what we start with, so we know we factored correctly. Okay, let's look at one more that uses the GCF. So I'm going to call this part C for this example. And so we're going to factor the expression x squared times x plus 3 plus 5 times x plus 3. So this one looks a little different maybe than what we're used to seeing. We've got 2 terms here. Remember, terms are separated by adding and subtracting. So my first term is this x squared times x plus 3 term. And then my second term is 5 times x plus 3. So we're going to think of like this is one term, and this is one term. So between those two terms, what do they have in common? So hopefully you see that they have the x plus 3 in common. So even though it's a binomial, it's still what they have in common. It's the GCF. So I'm going to take the x plus 3 out front, and because it's a binomial, I'm going to leave it in parentheses. And then because I started with two terms, when I open the parentheses, remember it's the reverse of the distributive property, when I open parentheses, I need to have two terms in my parentheses. So x plus 3 times what gave me x squared times x plus 3. So what's missing for that first term is the x squared. And then we need to have two terms in the parentheses, so it's going to be plus x plus 3 times what gives me 5 times x plus 3. And hopefully you see it's just the 5 that's missing for that second term. This one looks a little different, but we're going to see this pattern again. That's why I wanted to show it to you. So that's completely factored. So the first thing you want to do when you factor is look for a GCF. So once you've taken out the GCF, the next thing you want to do is count the number of terms. If there are two terms, we're going to look for either a difference of squares or a difference of cubes. This is on that roadmap. Make sure you're looking at the roadmap handout so you can see what I'm talking about. And we'll come back to two terms in a minute. If there are three terms, there's a couple techniques we're going to use for three terms. But go down to the bottom of that handout and it talks about what to do if there are four terms. So if there are four terms, we're going to factor by grouping. And I'm starting with this four terms factoring by grouping because we're going to use it to do some other things in a minute. So let's do an example where we factor by grouping. So we always want to factor by grouping when there are four terms, and that's the key thing to remember. So let's look at an example. X cubed plus 4x squared plus 3x plus 12. So we want to factor that expression. And first of all, notice there's no GCF. The first three terms have x's in it, but the fourth one does not. So we can't take out an x. They all have a 1 in common. Remember, there's a 1 in front of this x cubed. So 1 would be the only GCF. So the 1 doesn't really help us. So there's no GCF here, but there's four terms. So to factor by grouping, what we're going to do is we're literally going to group the first two terms in their own set of parentheses, and then we're going to group the second two terms in their own set of parentheses. Now, notice I kept that plus sign with that 3x, that third term. I know it looks a little funny. We don't really need the plus sign there, but I think whatever that term is, positive or negative, you keep it with that third term. That's going to make it a little bit easier for you. So what I want you to do is look at the first set of parentheses. Is there a GCF we can take out of both of those terms? Hopefully you see that they have x in common, and the lowest powered x is x squared. So I'm going to take out x squared from just those first terms, and then that leaves me with what in the parentheses? I need two terms, and it's going to be x plus 4. The second set of parentheses, ask yourself 3x and 12, what do they have in common? The only thing they have in common is a 3, and since that third term is positive 3x, I'm going to take out a positive 3. That plus sign is important, so write that plus sign there. And then what, if I were to redistribute the 3, would I need to multiply by to get 3x plus 12? And hopefully you see again, that would be x plus 4. Now, I want you to notice that what's in the parentheses is the exact same, x plus 4 in both parentheses. That's not a coincidence. When you group factor, they should be the same. And if they're not, if the first one is different from the second one, check your GCFs because maybe you took out the wrong thing. They have to match if it group factors. Now, we're basically where we were at the start of that last example, where we had two terms that had x plus 3 in common. This time we've got two terms, so this x squared times x plus 4 is one term, and then the 3 times x plus 4 is another term, and they have x plus 4 in common. So I'm going to take out now x plus 4, and then I'm going to open up another set of parentheses. The first term is missing x squared, and the second term is missing a positive 3. And that's group factoring. So we group the first two, take out the GCF, group the second two, take out the GCF, and then whatever they have in parentheses that's common, we take that out and put the remaining terms in parentheses. That's group factoring. Let's do another one. Okay, so I'll call this example B. We've got x cubed plus 5x squared minus 2x minus 10, and we want to factor this expression. So first, just make sure you see there is no GCF. There could potentially be a GCF, even though there's 4 terms. We could still have a GCF among those 4 terms, but we don't. So I'm going to go ahead and group factor because there's 4 terms. So I'm going to group the first 2, group the second 2, and notice it was a negative 2x for that third term, so I'm going to keep that negative with it. So take out the GCF for the first 2 terms. I'm going to take out x squared, and that leaves me with x plus 5. In the second 2 terms, they have a 2 in common, and because that third term was negative, I'm going to take out a negative 2. So notice that I took out a negative 2. So what would I need to multiply negative 2 by that would give me negative 2x? Well, that would have to be a positive x. And then also, what would I multiply negative 2 by to give me negative 10? It would have to be a positive 5. Pause and make sure you see that those 2 parentheses are the same. They're both x plus 5. If you're ever unsure or something doesn't match, check that first one because the first one we usually do correctly. Use that one as your guide. So if you had x plus 5 here, see if you notice that they match. They're both x plus 5. So now we can go ahead and take out the x plus 5 that they share. And then I'm left with x squared minus 2 in the other parentheses. And that's group factoring. Okay, so now let's take a look at what to do when we have 3 terms. So you'll notice on your roadmap handout there, it may ask you to make the distinction between whether or not the leading coefficient, so that A, that leading coefficient, whether or not that's 1. So let's start out with the case where A equals 1. So the coefficient on the x squared is 1. So what we want to look for here is we want to look for 2 numbers that multiply to give us 8, but add to give us the b value of 6. Okay, so we're looking for factors that multiply to give us 8, but add to give us 6. So this is going to break down, a trinomial always breaks down into 2 binomials. So when a is 1, I go ahead and I just write the 2 parentheses on my paper. This little sort of X or diamond here I have is just to help me organize the numbers. I'm looking for factors of 8 that add to 6. We could make a list. We could say 1 and 8, 2 and 4, and hopefully you see this is pretty straightforward. We're just going to have 2 and 4 because 2 times 4 is 8, 2 plus 4 is 6. So we go back to my parentheses. We know the first terms are going to be x and x because x times x gives us x squared, and we need 2 and 4. So we're going to have plus 2 plus 4. Everything's positive. The 6 is positive. The 8's positive. Everything's positive. So that's going to be the breakdown for that trinomial. We could always check it if we wanted to by multiplying it back out. Remember the FOIL method? So if we did the first terms, we would have x squared. The outer terms, we would have 4x. The inner terms, we would have 2x. And then the last terms, we would have 8. And of course, if we combine like terms, that would give us back what we started with. So we know we factored it correctly. Let's try another example where a is still 1. So we've got x squared plus 3x minus 18. We want to factor that expression. First, notice that there's no GCF here. So we're going to go ahead and go right to our method. I like to draw this little diamond just to keep my numbers organized. I'm looking for numbers that multiply to negative 18 this time, but add to positive 3. I think it's helpful if you think about the signs first. If I have to multiply to a negative, that means the signs have to be opposite, right? One of them positive, one of them negative. So I'm going to go ahead and put a plus sign here and a minus sign here to just remind myself that the signs have to be opposite. So if I'm looking for numbers that multiply to 18, negative 18, and add to positive 3, that means the difference between the numbers has to get me to 3. So factors of 18 would be 1 and 18, 2 and 9, or 3 and 6. I think those are all the possible pairs. So the difference between 3 and 6 is 3. So that has to be the combination. Which is positive, which is negative? Well, I need to get to a positive 3. That means the larger number here has to be positive. So that means that the 6 is going to be the positive and the 3 is going to be the negative. So since a was 1, we're going to go right to our 2 parentheses. We know the leading terms are going to be x and x. And then my numbers are going to be plus 6 and minus 3. And that would be our final breakdown. If we wanted to check it by foiling, we could, and we'd see we get back what we started with. So when you have a trinomial where a is 1, that leading coefficient is 1, the process is pretty straightforward. You just want to look for two numbers that multiply to the c value and add to the b value. Just watch your signs, set up your two parentheses, and fill in the numbers. It's a little more complicated when a is not 1. So let's look at some examples. So this is part 2 when you have 3 terms on your roadmap. There's a couple of different ways you can do this. So when a is not 1, you can still just set up your two parentheses and guess and check. I have no problem with that if you want to guess and check. It might be what's called a perfect square trinomial. I'll talk about that in just a minute, but let's pretend we don't know anything about that just yet. Let's look at number 2 on your paper. It says use the AC method. So let me show you what the AC method is. You may or may not have seen this before. I think this is better than guess and check, especially if you're not sure about your numbers. What we're going to do, well, here, let me give you an example first. Let me write down a problem we can look at. Let's look at 8x squared minus 10x minus 3. So we've got a trinomial. A, the leading coefficient is not 1. We can see it's 8. There's no GCF or anything like that. So let's go ahead and use this AC method. So what the AC method is we're looking for numbers this time that multiply to A times C. So the product of A and C. In this case, A is 8, C is -3. And then we want two numbers that multiply to AC but still add to B. B is still that middle number, -10. So in this case, A times C, 8 times 3 is -24. So I'm looking for numbers that multiply to -24 and add to B, which is -10. So this time we're looking for factors of -24. First of all, we know it's got to multiply to a negative number, so again, the signs have to be opposite. I like to put that in first. So I'm going to put a positive here and a negative here, just to help me keep everything organized. You could put the negative first and then the positive. That makes no difference, but the signs have to be opposite. So we're looking for factors of 24 whose difference gets me to 10. So if we write them in pairs, we could say 1 and 24. That's a pair of factors. 2 and 12. That's another pair of factors. 3 and 8 multiplies to 24. 4 and 6. Notice how I did that very systematically. I started with 1 and the number, and then I went to 2 and its factor, 3 and its factor, and so forth. I think these are all the factors of 24, and hopefully in that list you see that there is a combination where the difference between them is 10, and that would be with the 2 and the 12. Which one's positive, which one's negative? This time we need to get to a -10, so that means the larger number needs to be negative. That means we're going to have a -12 and a +2. So here's why I showed you group factoring first. Let me come back over to the question. I've got 8x squared minus 10x minus 3. So what I'm going to do is I'm going to rewrite this trinomial using -12 and 2. I'm going to break it down into 4 terms. Let me show you what I mean. 8x squared is the first term. I'm just going to write that down. Positive 2x. So I'm using the 2 from my pair of factors, and I put x because the middle term has an x on it. And then I'm going to write -12x. So all I did was I took that middle term, that -10x in the middle, and I broke it down into positive 2x and -12x, and then bring down the -3, the c term at the end. So I've taken the original 3 terms and I've broken it into 4 terms. That middle term I just broke up into these 2 factors using the numbers I found over here. So now I have 4 terms. So whenever we have 4 terms, we're going to group factor every single time. So I'm going to group the first 2, group the second 2. In the first 2, what is the GCF that I can take out? Hopefully you see by now that it's 2x. And so then that leaves me with, let's see, 4x plus 1. In the second 2, I have a -12x minus 3. It's negative, so I'm going to take out a negative. And then these also have a 3 in common, so I'm going to take out a -3. And then remember the parentheses have to match. So if I got 4x plus 1 here, I better get 4x plus 1 here. And I do, because -3 times 4x is -12x. -3 times +1 is -3. And so now I'm going to take out the 4x plus 1 that they have in common. And then my other parentheses is going to be 2x minus 3. So I factored that original trinomial down into these 2 binomials using the AC method. And we could always check it by FOILing. We'd get back what we started with. Let's do another example using that AC method. So let's take a look at this trinomial here. We've got 2x squared minus 7xy plus 3y squared. This time we have two variables. That's okay. The way we're going to get the numbers is the same. Notice the leading coefficient a is not equal to 1. So I'm going to use the AC method again. I'm going to multiply a times c. So a is 2, c is 3. So that gives me a positive 6 for a times c. And then b goes on the bottom. That gives me a negative 7. So I'm looking for two numbers that multiply to a positive but add to a negative. So if they multiply to a positive, the signs have to be the same. And if they add to a negative, both signs then have to be negative. So factors of 6, that would get me to 7 when I add them together. Well, it would either be 2 and 3, well, let's say 1 and 6 or 2 and 3. Those are my only options. And you'll notice that 1 and 6 adds up to 7. So it has to be a negative 1 and a negative 6. The order you put these in the little diamond does not matter. I could put negative 6 here, negative 1 here. I could switch them. It would make no difference. And over here, I'm going to rewrite the trinomial, break it down into those four terms. So I'm going to copy the first term, 2x squared. I'm going to use my numbers, so it's negative 1 xy. I'm using xy because that was the middle term there. And then negative 6 xy. And then I'm going to rewrite the last term, 3y squared. So notice that negative xy and negative 6xy is negative 7xy. I just broke up that middle term. So now I have four terms. We're going to use group factoring. So group the first two, group the second two. So the GCF for the first set of parentheses is just x. So I'm going to take out an x, and that leaves me with 2x minus y. For the second set of parentheses, I've got a negative, so I'm going to take out the negative. They also have a 3, and they have a y in common. So what would I need to multiply negative 3y to give me negative 6xy? And that would be 2x. What would I multiply negative 3y by to get positive 3y squared? It would have to be a negative y. And you notice what's in the parentheses now matches, as it should when we group factor. So I'm going to take out what they have in common, 2x minus y, and x minus 3y is going to be the other set of parentheses. Okay, so there's one more type of trinomial that may come up from time to time, and that's called a perfect square trinomial. So on your roadmap, if a is not 1, you may want to check to see if it's what's called a perfect square trinomial. Let me give you an example of what I'm talking about. So this is example 5, and we're talking about perfect square trinomials. If you recognize that you have a perfect square trinomial, it may save you a little bit of work. So we've got x squared plus 6x plus 9. Let's start with a pretty simple example. And we could still say, okay, a is 1, so all I'm looking for are numbers that multiply to 9, add to 6, multiply to 9, add to 6. That would be 3 and 3. So this one's pretty straightforward. But what you also should observe here is that x squared is a perfect square and 9 at the end is a perfect square. So if you notice that the first term is a perfect square and the third term is a perfect square, the middle term is even, check to see if it's a perfect square trinomial, meaning what's in the two parentheses matches. So we would have an x here and an x here. And then if we put a 3 here and a 3 here, because that's the square root of 9, everything's positive, does that give me 6x in the middle? And in fact, it does. So we could leave the answer as x plus 3x plus 3. There's nothing wrong with that. We could also write it as x plus 3 squared as a shorthand way of writing it. Either of those answers would be acceptable. Let's look at another perfect square trinomial. Let's look at one that's a little bit more involved. How about 25 x squared minus 60x plus 36? We could use the AC method. We could multiply 25 and 36 and get that product. I think it's 900 if I'm not mistaken, 900 here, and find two numbers that multiply to 900 and add to negative 60. However, I really don't want to break down 900, it's a pretty big number. So notice that the first term is a perfect square, the third term is a perfect square, and the middle term is even. So this makes me think maybe this is a perfect square trinomial. So if I break it down using those perfect squares, does that give me the middle term of negative 60x? So 25x squared would have to break down into 5x and 5x. 36 would have to break down into 6 and 6. 36 is positive, but the middle term is negative, so that means these would both have to be negative. And we could always check this just to make sure we're right by foiling it back out. The first term would be 25x squared. The outer term would be negative 30x. The inner term would be negative 30x. The last term would be 36. And so if we combine like terms, we see that that does give us what we started with. So if you're ever in doubt, just multiply it back out. And remember, we can also shorten this up and write this as 5x minus 6 quantity squared. So this answer would be acceptable. This answer would be acceptable as well, your choice. Okay, there's one more type of factoring we haven't discussed, and that's what to do if you have two terms. Okay, so if you have two terms, often the only thing you can do is take out a GCF. So keep that in mind. Sometimes GCF is all you can do. If you have two terms, three terms, four terms, whatever. But sometimes when you have two terms, you may have something called a difference of two squares. So this formula is on your roadmap. If you look back under the two terms section, you'll see this formula. And its difference, of course, means subtraction. So remember, that's a squared minus b squared. So the difference of perfect square minus another perfect square. That will break down into a plus b times a minus b. So two binomials where the signs are opposite. Let me give you an example here. So suppose we were given x squared minus 49. Notice there's only two terms. There's no GCF, but it's a difference of squares because I have something squared minus something else squared. So I'm going to break this down into its square roots. So the square root of x squared is, of course, x. So we have x and x. The square root of 49 is 7. So 7 and 7. One's positive, one's negative. Does not matter the orders you write these in because remember you're multiplying, so you can go in either order. So we could have written x minus 7 times x plus 7. That would have worked just fine. Either way you write it is fine. Let's do another quick example here. Let's take a look at 16x squared minus 25y squared. So again, we only have two terms. There's no GCF. The first term, notice, is a perfect square. What is the square root of 16x squared? That would be 4x. And the square root of 25y squared would be 5y. So if we break it down using our GCF, our difference of squares formula, we'll have 4x and 4x plus 5y minus 5y. And if we FOIL this back out, I'm skipping the details now, but if we're ever in doubt, FOIL it back out and you'll see that the middle term cancels and just leaves you with the two terms that you started with. There's one more type of thing you may come across, type of factoring that might come across. Okay, so let's do another one here. We've got x squared plus 81. So we've got a perfect square, x squared, and 81, of course, is a perfect square. But what's a little different about this one? Hopefully you notice compared to the last two that we looked at. We're adding these squares. We're adding these squares together. It's not a difference of two squares. It's called a sum of two squares. And we cannot factor a sum of squares. So remember, if something can't be factored, that means it's prime. So there's nothing we can do when we have a sum of two squares. There's one more type of factoring that you may come across from time to time, and that would be a difference of cubes or a sum of cubes. So again, we're working with two terms, and instead of working with squares, we're working with cubes. Let me give you an example. X cubed minus 8. So x cubed, of course, is the cube of x. 8 is a perfect cube. What's the cube root of 8? And that would be 2, because 2 times 2 times 2 is 8. So this is a difference of two cubes. And if you look at your roadmap handout, It says step 3 there at the top, it says, is this a difference of cubes? And if it is, there's a formula for it. Let me give you the formula. So a cubed minus b cubed, once you establish a and b, that breaks down into a minus b times a squared plus ab plus b squared. This is going to follow the same pattern every time. You're going to have a binomial times a trinomial, minus here, plus and plus here. So in this example, a is just x, b is the cube root of 8, which is 2. So this is going to break down into x minus 2 times a squared, which would be x squared, plus ab, so that would be 2 times x, so 2x, plus b squared, which would be 2 squared, which gives us 4. And that's it. This trinomial does not break down any further. You'll waste your time trying to break that down. This is it. It's a binomial times a trinomial. And that's it. There's one more type of cube formula we need to know, and that is a sum of two cubes. Let me give you an example. 27x cubed plus 64. So we have a sum of perfect cubes. 27 is a cube of 3. 3 times 3 times 3 is 27. 64, it's a perfect square, but it's also a perfect cube. 4 times 4 times 4 gives you 64. So if you look at your handout there, we have a formula for the sum of cubes. So it breaks down like this. A cubed plus b cubed turns into a plus b times a squared minus ab plus b squared. And that's the formula we're going to use. So we need to figure out what is a and what is b in this example. A would be the cube root of 27x cubed. So that'd be, I'll write it out, that'd be 3x. And b is the cube root of 64, which is just 4. So let's put this together using that formula. So we're going to have 3x plus 4, and then another parentheses, a squared. So think about 3x squared. I have to square both the 3 and the x. That gives me 9x squared minus a times b. So 3x times 4 gives me negative 12x plus b squared. Well, if b is 4, b squared would be 16. And that's it. That's as far as that breaks down.